Okay, we're going to solve a moles to moles problem now. So there's a couple of points that I want you to keep in mind as we solve one of these problems. First, recognize that you must have a balanced chemical equation. Now, if you're in regular level chemistry, they're probably going to give you the equation balanced already, so you don't have to do anything. But if you're in honors or AP level chemistry, then you have to double check and make sure that the equation that was given was actually balanced. All right, now once you can confirm that that's true, then you can go on to the next step. Now the next step just involves looking at the coefficients of the substances that are involved. Don't worry if there are more than two substances in the problem. There probably will be, okay, but you really only need to focus on the two that the problem calls for. Those coefficients are the molar ratios, and those are very important because the molar ratios tell you how the proportions work. Kind of like when you're making a cake and you need to know how many cups of flour to how many cups of sugar. That kind of proportion is what I'm talking about. Those are the molar ratios. Now, when you know the molar ratios, you can create a conversion factor, and that conversion factor is built from the molar ratios of the substances in the problem. And you're going to use that to figure out how to convert from moles of A to moles of B. All right, here's the video, and I'll see you afterwards. Okay, so here we have a moles to moles problem, another example for you. This is a problem that involves one of my favorites, potassium chlorate. And what's happening in this reaction is potassium chlorate is decomposing. It's breaking apart into two different things, potassium chloride and molecular oxygen. Now, this moles to moles problem involves a balanced chemical equation. Everything that I set up here is balanced. If you're in regular chemistry, chances are you're going to be given an equation that is balanced. But if you're in honors or AP level chemistry, make sure that you check and double check that you're dealing with a balanced chemical equation. Super important. All right, let's read the problem and figure out what they want here. Okay, so if 6 moles of potassium chlorate decomposed, how many moles of oxygen will be produced? All right, well, let's check it out. Here, the given information is this. And what we're looking for is moles of oxygen gas. So, okay, fine. So if we have moles of oxygen gas, then we need to find that. So our problem's only going to involve this substance and this substance. We don't even need to worry about this potassium chloride because it's not part of our problem. Yes, it's part of the original equation, but it's not involved in what we're trying to solve here. So the given information is what we're going to start with. And so here we go. Starting with 6 moles, again, using MOL as an abbreviation for moles. Don't ask me why, I didn't make the rules, I just follow them. And then what we have to do here is we have to come up with some kind of conversion factor. Okay, now the conversion factor is going to be pulled from the equation. This is going to tell us that for every 2 moles of potassium chlorate, there are 3 moles of molecular oxygen. So what I'm going to do now is I'm going to write 3 moles of O2 on the top, and I'm going to write 2 moles of KClO3 in the bottom. And my reason for doing that is because I want the moles of KClO3 here to cancel with the moles of KClO3 down here. Okay, so right here, this little piece of the puzzle, this is what chemistry teachers mean when they say mole ratios. Okay, here the ratio is 3 moles of oxygen to 2 moles of KClO3. It actually works upside down and vice versa as well, but you have to arrange this for the situation you're dealing with. Right now I've got moles of KClO3 here. I want to make sure that they cancel over here. Done and done. So in the end, all I'm going to do now is multiply 6 times 3 and divide by 2. Remember, we're not canceling the numbers, we're canceling the units. And then you just work out the multiplication and the division steps here. So 6 times 3 is 18, divided by 2 is 9. So then this problem works out to be 9 moles of oxygen. And that, my friends, is how you roll when it comes to moles to moles. Okay, you just got done watching the moles to moles video. So let's recap the most important points. First, you must start with a balanced chemical equation. Can't get around that. If you're in regular level chemistry, they're probably going to give it to you, but if you're in honors or AP, watch out, okay, because they do like to trick you with that stuff. Second is, once you have the balanced equation, you look at the coefficients. The coefficients give you the molar ratios between the different substances, and then from that, you're going to create a conversion factor. I recommend that you take the time to download the worksheet and solve this problem on your own and follow all the steps. Even if you know how the problem is supposed to be solved, just the act of taking the steps and following the steps and practicing the steps is really what is going to train your brain for following the correct procedure in these kinds of problems. All right, that's all I have. Watch another video, and I'll see you next time.